Hello friends, today I am here to discuss one of the mechanical properties of material, that is toughness. I am Ranjan Kumar, lecturer in mechanical engineering. I have done my BTech from IIT Jamshedpur. So let's first define toughness. Toughness is the ability of a material to absorb energy up to the fracture point. What does it mean? We, if we are applying a stress to a material, the material will start deforming elastically at the initial phase. Then it will be there will be plastic deformation, and finally it will fracture at the fracture point. So the energy absorbed in the process of deformation from initial uh, point to fracture point is known as toughness. The energy absorbed up to the fracture point is known as the toughness. Essentially, it is the resistance to fracture under stress. How it is calculated? It is calculated as the area under the stress strain curve. I will show you in the stress strain diagram. This is the stress strain diagram. This stress strain diagram represents is for the brittle material, and this is for the ductile material. We can the area under the curve of both represent the toughness. We can see the area under the curve of brittle material is much lesser compared to the area under the curve of ductile materials. It means larger area under stress strain curve represents high toughness, and lower area represent low toughness material. So brittle materials are less tougher than the ductile material. Uh, so when the area under the stress strain curve is large, the material will have high toughness, and it will absorb large amount of energy before fracture as compared to the brittle one. Next point is, for material to have high toughness, it should have a good balance of both ductility and strength. Low strength material and brittle material tend to have low toughness. I will explain this point from the stress strain diagram again. This is the stress strain diagram. I am representing stress on y-axis, strain on the x-axis. If this is the stress strain diagram for material A, this is the fracture point, this is the ultimate strength, and this is the yielding point. For second material, I will represent. We can see the fracture point of both material A and B is at same point, at same strain level. Means same deformation is taking place in both. But the strength of both material is different. Material A ultimate strength of material A is much higher than the ultimate strength of material B. So we can see both are having almost same ductility but different strength. The material A will have much more area under the curve as compared to the material B. So material A will be more tougher than material B in this case. I will take you the next. I will show you the next case. This is the stress strain diagram again. Here I will vary ductility. One material is failing over point here A, another is failing at point B. So both are having same ultimate strength. Ultimate strength of both material is same. So up to this the area will be less as compared to area under curve for B. So in this, toughness for B will be higher than A. So we can see that ductility and strength plays an important role in toughness. There should be good balance of both to have a good uh, toughness of material. Similarly, low strength material and brittle material tend to have low toughness. Thank you.